Okay, so the next question that we have is question number 10, which is basically a geometric progression, which is basically x cubed, x raised to the power 5, x raised to the power 7, and so on and so forth. We want to find the sum of the first n terms of this geometric progression if basically x is not equal to plus or minus 1. I think if x is equal to plus or minus 1, then you will get into trouble here, meaning that it would not be a geometric progression. I think that would happen, but then basically you can see that your common ratio is x raised to the power 2, r is equal to x raised to the power 2, and your a is equal to x raised to the power 3. That means that you can write s of n, which is equal to 8 times basically r raised to the power n minus 1 over r minus 1. You can write it as a, which is equal to x raised to the power 3, r is x raised to the power 2 raised to the power n, which would be x raised to the power 2n minus 1 over x raised to the power 2 minus 1. And I think you cannot simplify this any further, so they have written this as x raised to the power 3 times 1 minus x raised to the power 2 and 1 minus x squared. You can write it that way as well, which is basically the same thing. Question number 11 is you want to evaluate the sigma of 2 plus 3 raised to the power k for k is equal to 1 to 11. Okay, so I did make a mistake here, and that was a good mistake that I made, meaning that if you make a mistake and you learn from it, of course it's a good mistake. Or I would actually call it an interesting mistake that I made. You see over here, let me erase all of this. You see over here, what you can do is that you can write this as the sigma of basically the sigma of 2 plus 3 raised to the power k, as k goes from 1 to 11. You can, well, I mean that's basically the same thing as 2 plus 3 raised to the power 1, for example, plus 2 plus 3 raised to the power 2, and plus 2 plus, and you have sigma notation, so you have the plus signs over here, 2 plus 3 raised to the power 3 all the way up to basically 2 plus 3 raised to the power 11, right? So of course, in and of itself, it's not a arithmetic progression. It's not a geometric progression, meaning that, for example, this is 2 plus 2 is equal to 5. This is 11, and this is 29, and so on and so forth, all the way up to 2 plus 3 raised to the power 11, whatever that might be. So it's just not anything really that you could work with. But then what you can do here, you can actually make a geometric progression out of this, in that you take this 2 over here is not dependent upon k, meaning that as k changes, this 2 does not change. and so you could take that out. But when you take this out, you have to be careful how you take that out, meaning that you should not actually make the mistake that I made here. So so when you have basically 2 plus 3 raised to the power k, when you want to take that out, as you saw, as I had written the terms over here, let me basically show you the terms. So as you can see, 2 has been added to this sum as many times as you have, as many times as these terms have been added together, meaning that as large as your index, basically. So the upper limit of your index. So that means that this is actually not, when you want to take it out, the value of these 2's becomes 11 times 2, right? So when you take it out, you would write that as 11 times 2, not just 2. So this is the mistake that I made here. I wrote it as 2 times sigma of so on and so forth, which is actually not right. Now let's suppose that we had another situation, like for example the sigma of 2 times 3 raised to the power k, as k, for example, goes from 1 to 11, for example, the same index. If that is the case, then how would you take this 2 out? So this is multiplied by 3 raised to the power k. And so over here you can see that basically this would be basically 2 times 3 raised to the power 1 plus 2 times 3 raised to the power 2 plus 2 times 3 raised to the power 3 plus all the way up to 2 times 3 raised to the power 11, right? So which means that I can now take a 2, I can from here basically I can take a 2 out and write it as basically 3 raised to the power 1 plus 3 raised to the power 2 plus 3 raised to the power 3 plus all the way up to 3 raised to the power 11, right? And that's basically 2 times sigma of basically 3 raised to the power k, for example, as k goes from 1 to 11. So in this case, I could write this as, since this 2 is being multiplied by these terms, I could write this as 2 times sigma of basically 3 raised to the power k as k goes from 1 to 11, for example. This would be fine. This would be okay. But in this particular case, when I want to take the 2 out, I have to write it as, I have to write this as actually 2 times 20, 2 times 11, and then I can take it out because this is 11 2s, so I have to write 2 times 11, and since all of these 2's are being multiplied to the sum, then I can write it as plus, for example, the sigma of, for example, 3 raised to the power k as k goes from 1 to 11, right? And therefore now I have a geometric progression. Now I have a geometric progression, so that would be basically 22 plus sigma of basically 3 raised to the power k as k goes from 1 to 11. And that's 3 raised to the power 1 plus 3 raised to the power 2 plus 3 raised to the power 3 and so on and so forth, which means that it would be a geometric series where basically your a is equal to 3 and your common ratio is equal to 3 as well, right? because this would be basically this part over here would be basically 3 plus 3 raised to the power 3 raised to the power 1 plus 3 raised to the power 2 plus 3 raised to the power 3 plus all the way up to 3 raised to the power 11. So you can see that your first term is 3, and every time that you jump to the next term, your term is being multiplied by 3 and 3 and 3 and so on and so forth. So your common ratio becomes 3. So so that means that then I can write this as this sum. I can use the formula A or S of n is equal to basically A times r raised to the power n minus 1 over r minus 1, and therefore S of n would be equal to basically, or S of, I could say S of 11. I could say S of 11 is equal to A, which is equal to 3 times basically 3 raised to the power 11 minus 1 over basically 3 minus 1, which is equal to 3 minus 1 is equal to 2, so that's 3 halves times 3 raised to the power 11 minus 1. Right? And so you would have basically this part would be 22 plus 3 halves times 3 raised to the power 11 minus 1, and that would be basically your sum. That would be your sum. That is the correct answer. You need to be careful about the sigma notation. It's sometimes a little bit tricky. Okay. So the next question that we have is question number 12. It's question number 12. Let's see what that is. Okay, so question number 12 is basically the sum of the first 3 terms of a GP. The sum of the first 3 terms of a GP is 39/10. So basically the sum of the first 3 terms of a GP is 39/10, and their product is 1. And their product is 1. Find the common ratio and the terms. Find the common ratio and the terms. So basically the sum of these terms is basically 39/10, meaning that well, this is the same problem that we had before in the examples, and the way that you can solve this problem is that you have to actually follow the same unusual way of solving the problem, meaning that you should, I mean, the only way that I know actually that you can solve this problem is only based on the example that I have seen in the text, which is of course there must be other ways probably, but I really don't know of them. So you can say that let the first 3 terms of the GP be basically, you have to take the first term. Normally you take the first term as A, and then the second term a times r, and the third term a times r squared, for example, right? Because r times a is equal to a times r, and r times ar is equal to ar squared. But if you divide the whole thing by a factor of r, you'll get a divided by r and a, and so let me actually do this so that we don't make mistakes here. So you get a divided by r and ar divided by r and ar squared divided by r. And so you will get basically, you will have basically a divided by r and a times r. So you have to actually choose your terms this way, otherwise there is no way to solve this problem. I mean, as far as I know, of course. So a divided by r and a times r, let the first three terms be these terms over here, right? And then we said that the sum of these three terms is basically 39/10, meaning that a divided by r plus a ar is equal to 39/10. And the product is 1, meaning that a divided by r times a times r is equal to 1. And then r and r you can cancel out, so you'll get a cube is equal to 1, meaning that if a cube is equal to 1, that means that a has to be equal to 1, right? Because you cannot choose -1 here, so that a has to be equal to 1. So what that means is that then you can put your a over here and write this as basically 1 divided by r plus 1 plus r is equal to 39/10. And so you can multiply the whole thing by a factor of r to get rid of this r over here. So I write that the rest over here, r times this would be equal to 1 plus r squared is equal to 39/10 times r. And therefore you would have basically 1 plus r minus 39/10 times r plus r squared is equal to 0. 1 plus r minus 39/10 r plus r squared is equal to 0. And so you have r squared plus r times 1 minus 39/10 plus 1 is equal to 0. And you can take basically 1, you can take it as 10/10. So 1 minus 39/10 is equal to 10/10 minus 39/10, which is equal to negative 29/10. So you can write it as r squared minus 29/10 times r plus 1 is equal to 0. And then you can multiply the whole equation by a factor of 10 to get rid of this 10 over here. So that's 10 times r squared minus 29r plus 10 is equal to 0. And then you can, then 10 times 10 is equal to a, are we supposed to find the common ratio here? Yes. Okay. So 100 is the same thing as 2 times 50 and that's 2 times 25, and that's the same thing as 2 times, actually 5 times 5. There might be actually something wrong here, because okay, so you can take 25 and 4, that would be 29, right? And take negative 25 and negative 4, which would be negative 29, and when you multiply them together, you get positive 100, which is the product of these two numbers. So you can write 10r squared minus 25r minus 4 times r plus 10 is equal to 0. So then you can write this as basically 5r you can take out from these two terms and write it as 2r minus 5 times minus 5, and negative 2 you can take out here and take it as basically 2r minus 5 is equal to 0. And so 5r minus 2 times 2r minus 5 is equal to 0. That means that basically 5r minus 2 is equal to 0, or 2r minus 5 is equal to 0. This means that 5r is equal to 2, or r is equal to 2/5, or basically 2r is equal to 5, and r is equal to 5/2. So in both cases, it seems that you would have basically, so if your a is equal to 1, and then you would have a geometric progression, because if you have a by r, and r is supposed to find the terms as well. Okay, so if your terms are a by r and a times r, then basically if r is equal to 2/5 and a is equal to 1, then you will have 1 divided by 2/5, which is equal to 5/2, and then a is equal to 1, and then a times r would be equal to 2/5, right? So then 1 divided by 5/2 is equal to 2/5. 2/5 divided by 1 is equal to 2/5. This is a geometric progression. Again, the terms a divided by r, a and a times r. This time, if r is equal to 5/2 and a is equal to 1, then you will get basically 1 divided by a divided by r would be 1 divided by 5/2, which is equal to 2/5. And then a is equal to 1 again, and then a times r would be equal to 5/2. So again, the common ratio would be here 5/2 and 5/2, so that would be again a geometric progression. Okay, so that was question number 12. Question number 12. Okay, so the next question that we have is question number 13, which is how many terms of the GP, basically 3 squared, 3 raised to the power 3, and so on and so forth, are required to give the sum of 120. That means that S of n is supposed to be equal to 120. And so how many terms do you need in order to get the sum of 120? So here basically this is of course a geometric progression. and your A is equal to 3, and your R is equal to 3 as well, because every time 3 is multiplied by the previous term to get to the next term. And you know that S of n is equal to A times R raised to the power n minus 1 over R minus 1. So if I take S of n as 120, I would have basically 3 times R raised to the power n, which is equal to 3 raised to the power n minus 1 over 3 minus 1, R minus n, R minus 1, which is the same thing as basically, 3 halves. This is 3 halves, so 120 is equal to 3 halves times 3 raised to the power n minus 1. Multiplied by 2, you will get 240 is equal to 3 times 3 raised to the power n minus 1, which means that 3 raised to the power n minus 1 is equal to 240 divided by 3, which is equal to 3 raised to the power n minus 1 is equal to 880, which means that 3 raised to the power n is equal to 81, right? Now 81 is the same thing as 3 raised to the power 4. 3 raised to the power n is equal to 3 raised to the power 4. That means that n is equal to 4, which means that you need 4 terms of that geometric progression. The first term is 3, the second term is 9, the third term is 27, and the fourth term is 3 raised to the power 4, which is equal to 81. Add these together, you'll get 81, 27, and 9 plus 12. So you'll get 801 and 10, 12, 120, right? Okay. So this was easy. Question number 14. The sum of the first 3 terms of a GP is 16 and the sum of the next 3 terms is 128. Determine the first term, the common ratio, and the sum to n terms of the GP. So over here we have the sum of the first 3 terms is 16, right? So I have to write this down. The sum of the first 3 terms, of a GP, terms of a GP is 16, and the sum of the next 3 terms is 128, and the sum of the next 3 terms is 128. Determine the first term. You want to determine the first term, the common ratio, and the sum to n terms of this GP. So I think I already know how to solve this problem. Oh, where? No. See over here. So let's say that your GP is basically A of 1, A of 2, A of 3, A of 4, A of 5, and A of 6, and so on and so forth. So here we are saying that the sum of the first 3 terms of this GP is 16. So that means that here S is equal to 16. And the sum of the next 3 terms, is 128. The sum is S is equal to 128. Now, you see that we have actually no formula to calculate the sum of to sum of the terms from a of 4 all the way up to a of 6. We don't have a formula to do that. And so we have to basically make some arrangements here, meaning that I can say that basically this sum over here, which is equal to 128, I can say that basically S of 6, for example, the sum of these 6 terms is equal to 16 plus 128, right? And then S of 6 is equal to 16 plus 128, which is the same thing as 128 plus 16. That's equal to 14,1, and that's 144. S of 6 is equal to 144. From that I can calculate S of 6. And for S of 6 I have a formula. And this sum over here is actually S of 3. I know that S of 3 is equal to 16. If I call this equation number 1 and call this equation number 2, therefore I can say that S of, for example, I can say that S of 6, which is equal to 8 times, for example, let's say that S of n is equal to 8 times r raised to the power n minus 1 over r minus 1. Let's consider it that way. Then I know that basically 144, which is S of 6, is equal to basically 8 times r raised to the power 6 minus 1 over basically r minus 1, right? And that is basically from equation number 1. From equation number 2, I can write basically 16 is equal to, that is S of 3. So that's 8 times r raised to the power 3 minus 1 over r minus 1, right? And now if I divide 1 by 2, for example, if I divide 1 by 2, I will have 144 divided by 16 is equal to 8 times r raised to the power 6 minus 1 divided by r minus 1, and divide that by r, 8 times r cubed minus 1 divided by r minus 1, right? Which means that then I could simplify these two together, and 144 by 16 is the same thing as 72, 8, 4, and 36, and 36 by 4 is equal to 9. That is equal to 9. And of course a and a you can cancel out here, so you will get basically what you will have is 9 is equal to r raised to the power 6 minus 1 over r raised to the power 3 minus 1. Now you need to find some way to cancel something out here. Okay, there is actually no way to do that. So if I cross multiply, I will get 9r cubed minus 9 is equal to r raised to the power 6 minus 1. And so r raised to the power 6 minus 9r cubed, and r raised to the power 6 minus 9r cubed, and then this 9 comes to the other side, becomes positive 9 plus 8 is equal to 0, right? And then what you can do is that you can take r raised to the power 3 as x, for example. R raised to the power 3 as x, so this becomes x raised to the power 2 minus 9 times x plus 8 is equal to 0. And in that way you can solve this equation. So 1 times 8 is equal to 8, so you get 1 and 8, and negative 1, negative 8, positive 8, negative 9. So x squared minus x minus 8x plus 8 is equal to 0, which means that x times x minus 1 times minus 8 times x minus 1 is equal to 0. X minus 8 times x minus 1 is equal to 0. That means that x is equal to 8 or x is equal to 1. So if x is equal to 8, then basically r cubed is equal to 8, which means that basically r is equal to 2, because that is 2 cubed, right? Which means that r is equal to 2. If x is equal to 1, then that means that r cubed is equal to 1, which means that that means that r is equal to 1. Now we have two values for r is equal to 2 and r is equal to 1. And so we can, over here, we can say that, for example, we said that over here, s of 3 is equal to, for example, 16, right? We said that s of 3 is equal to 16. So if s of 3 is equal to 16, then that means that basically s of 3, which is basically 8 times r raised to the power 3 minus 1 over r minus 1 is equal to 16. Now if r is equal to 1, we have a times 1 raised to the power 3 is equal to 1 minus 1 over basically 1 minus 1 is equal to 16. This becomes 0. I think r is equal to 1 is not acceptable, because if r is equal to 1, then 1 cubed minus 1 becomes 0, and this becomes 0, that you would be dividing 0 by 0. So r is equal to 1 is actually not acceptable. I cannot accept this value. But r is equal to 2, r is equal to 1 is not acceptable. But when r is equal to 2, we have basically the same equation here. 8 times basically 2 cubed is equal to 8 minus 1 times 2 minus 1 is equal to 1 is equal to 16. That means that basically that's 7a is equal to 16. That means that a is equal to 16 sevenths, right? 16 sevenths. And so you have basically a is equal to 16 sevenths, and your r is equal to 2, meaning that multiply 2 by this, you would get 32 sevenths, and multiply 2 by this one, you'll get 64 sevenths, and multiply 128 sevenths, and 256 sevenths, and 512 sevenths, and so on and so forth. There's 6 terms I have written here. And so if you add the first 3 terms together, you'll get 16 sevenths plus 32 sevenths plus 64 sevenths is equal to 7, and 16 plus 32 plus 64 is equal to 16, 32, 64 is equal to 12, 1, 6 plus is equal to 9, 9 to 112, 112 sevenths. Oh, there is something wrong here. And 12 sevenths is not 16, it's actually 16. Okay, it is equal to 16. Okay, so that actually works. I was not expecting that. And then the sum of these 3 terms, 128 sevenths plus 256 sevenths plus 512 sevenths is equal to 7, and 128 plus 256 plus 512, 128 plus 256 plus 512 is the same thing as 16, 1, 5 plus 5, 6, 7, and 9, and then you have 896 sevenths, 96 sevenths. And what is it supposed to be? 144. 896 sevenths is equal to 7, 1, 19. 2 times 4 is equal to 2 times 6 is equal to 14, 56. That's 828. 128. Oh, that's correct. That's supposed to be 128. Okay. So it works. It actually works. The solution does work. But basically the other value of R doesn't really work here. So your A is equal to 16 sevenths. Your A is equal to 16 sevenths. Your R is equal to 2, and the terms are the sum to n terms of the geometric progression. You can calculate that as well, meaning that you can write S of n is equal to basically A times R raised to the power n minus 1 over R minus 1. So S of n is equal to A, which is equal to 16 sevenths, times R raised to the power n, 2 raised to the power n minus 1. Divide that by 2 minus 1. So that's the same thing as 16 sevenths times 2 raised to the power n minus 1. That is the sum to the first n terms of the geometric progression. Let's take a look at the answer here. Question number 14. Question number 14. 16 sevenths, that's correct. And 2, that is also correct. And 16 sevenths times 2 raised to the power times 2 raised to the power n minus 1, that is also correct. Okay. That was question number 14. Let's see what we have in question number 15. Okay, so question number 15, we have given a geometric progression with a is equal to 729. We have a geometric progression, a is equal to 729, and the seventh term is equal to 64, a of 7 is equal to 64, and determine s of 7. Okay, so I actually solved this problem before, but I did have a little bit of problem with this problem, meaning that of course I got the correct answer and everything, but something is missing in the answer, and I will caution you against my I'm going to give you two solutions, or basically two values for R, but then it's up to you to take basically my value or not. I think that my solution, the second solution is also correct, but then use it based on your own discretion. If you think that basically my solution has problems, logically it has no problem, but it's not been mentioned in the solution, so I do not know why, but let's see how basically it goes. So basically the question is simple. The question is simple. You have a geometric progression in which the first term is 729 and the seventh term is 64. You want to determine s of 7. You want to determine s of 7. Okay. So to determine s of 7, you need to do the following. So basically, if I say that in a geometric progression, you know that basically a of n is equal to a times r raised to the power n minus 1, right? Which means that a of 7, which is equal to 64, is equal to a times, and a is equal to 729 here, is equal to 729 here, times r raised to the power n minus 1. And n minus 1 here is equal to basically 7 minus 1, which is equal to 6. That means that r raised to the power 6 is equal to 64 divided by 729. Okay. Now, 64. So first of all, 729 is 3 raised to the power 6. Okay. Because if you write 3 raised to the power 3 is equal to 27, and 27 times 27 is most probably 49, 4, 189, 0, and 14, 1, 5, 9, 12, 1, and 729. As you can see, this is 3 cube, and this is also 3 cube, so basically then this would be 3 raised to the power 6. So you can write this as 3 raised to the power 6, and 64 is basically 2 raised to the power 6, because 2 raised to the power 4 times 2 raised to the power 2, this is 16, and this is 4 times 16 is equal to 64, this is 2 raised to the power 6. Which eventually you can write as 2/3 whole raised to the power 6, right? Now, so over here basically I have r raised to the power 6 is equal to 2/3 raised to the power 6, and that means that basically Okay, now I see that you see the problem with this is that now if you write r raised to the power 6 is equal to 2/3 raised to the power 6, that means that r is equal to 2/3. Okay, I have no problem with that. But suppose that you have r raised to the power 6 is equal to 64 divided by 729, and if I say that if I said r is equal to 2/3, then r raised to the power 6 would be equal to 2/3 raised to the power 6, which is equal to 2 raised to the power 6 over 3 raised to the power 6, which is going to give us the solution here, and therefore this would be a solution, right? Meaning that this is of course equal to 2 raised to the power 6 over 3 raised to the power 6. On the other hand, I can say that if I said r is equal to negative 2/3, then r raised to the power 6 would be negative 2 over 3 whole raised to the power 6, and that would be equal to negative 2 raised to the power 6 over 3 raised to the power 6. And that would be the same thing as again the same story, meaning that negative 2 raised to the power 6 of course is equal to again the same number, 64, and 3 raised to the power 6 is equal to 729, and therefore negative 2/3 is also a solution. If I say negative 2/3 raised to the power 6 is equal to 64 by 729. Well, negative 2/3 would of course be a solution, right? It would be a solution. So which means that I can say that over here I can actually say that r can be equal to, I can say that, and that's basically the problem, that was the problem that I had with this problem. So here I can say that r is equal to negative plus or minus 2/3, right? So that is the and in the solution basically what has been given, basically only the positive 2/3 has been taken for whatever reason. I don't understand that. And of course, if you think about, for example, the problem itself, sometimes based on the problem you have to discard one value of your r, because in some cases it doesn't make sense that you take, for example, the negative sign. But over here, as you can see, your a is equal to 729, and then you have all of these terms as, for example, a2, a3, a4, a5, and a6, and a7 is equal to 64. This is basically a7, a of 7. So if r is a positive number, when I multiply it, and this number is a positive number, of course, right? So when I multiply a positive number by this, I'll get a positive, and again, basically r is multiplied by this, you'll get the next number. R is multiplied by this, you'll get the next number, and so on and so forth. Meaning that every time that I multiply the positive number by any of these numbers, I get positive, and this number is a positive number. So, of course, with the positive r, we have no problem. Now this number again is a positive number. This number again is a positive number, and this number is a positive number. Now if I take my r as a negative 2/3, if I multiply it by positive 729, that gives me a negative number here. Again, negative times negative is positive. Negative times positive, negative. Negative times negative, positive. Negative. And then again positive. So you have no problem there. But for whatever reason, the negative value of r has not been taken here. Now I'm taking both of the values, and then I will calculate s of 7 based on both of those values. But I just needed to tell you that basically the negative side of r has not been taken in the solution, and I've taken a look at two different solutions. They have, none of them have taken the negative value of r for whatever reason. Okay, so now to calculate s of 7, what you can do is, of course, you know that basically s of n is equal to a times r raised to the power n minus 1 over r minus 1, for example. Or you can write it the other way around, which would be, of course, the same thing. Now if you write s of 7, s of 7 would be equal to a, which is equal to 729, which is 729 times r. I'm writing r as just simply r for the reason. Raised to the power n, and n is basically 7 here, minus 1, divided by r minus 1. Now if r is equal to 2/3, we have basically s of 7 is equal to 729 times basically 2/3 raised to the power 7, whole raised to the power 7 minus 1, divided by 2/3 minus 1, and that would be equal to basically 729 is basically 3 raised to the power 6 is equal to 3 raised to the power 3. So 3 raised to the power 6 is equal to 3 raised to the power 3 times 3 raised to the power 3, which is equal to 27 times 27. So 27 times 27 is equal to 49, 1489, 0, and 2 times 7 is equal to 14, 1, and 4, 5, 540, so 9, 12, 1, 729. So that is equal to 729. That is basically 3 raised to the power 6. That means that basically 729 is actually equal to 3 raised to the power 6, right? And so what that means is that you can write this as basically 3 raised to the power 6, and this is 2/3 minus 1. 2/3 minus 1 is equal to basically 2/3 minus 3/3, which is equal to negative 1/3. Negative 1/3. And then if you divide, and then you have basically 3 raised to the power 6, divide that by negative 1/3. That's the same thing as 3 raised to the power 6 times the reciprocal of this, which is negative 3, which is the same thing as negative 3 raised to the power 7, right? So you can write this as you can write this as negative 3 raised to the power 7, and then over here you have you can multiply this negative sign by this expression. You can write it as 1 minus basically and 2 raised to the power, you can write this as 2 raised to the power 7 over 3 raised to the power 7, right? And so this becomes a positive, of course. Then what you will do is that you can write this as 3 raised to the power 7 minus 2 raised to the power 7. 3 raised to the power 7 is equal to 729 times 3, right? 729 times 3. 3 times 9 is equal to 20, 27, 2, 6, 8, and 21, 87. And 2 raised to the power 7 is equal to 2 raised to the power 6. 2 raised to the power 6 times 2, which is equal to 2 cubed times 2 cubed times 2, and that's 64 times 2, which is equal to 128, right? So that's, so you have to subtract 128 from this number in order to get the answer. So which means that then you have 2187, which is this number, and 128, which is this number, and then this becomes a 7, this becomes 17, 9, 5, 0, and 2, 2059, 2059, which is the answer that has been provided in the book. This is 2059. Okay, that is the answer that has been provided in the book based on the value of r is equal to 2/3. Now, if r is equal to negative 2/3, we have basically, we can use the same formula here. S of 7 is equal to 729 times basically negative 2/3 raised to the power 7 minus 1 divided by negative 2/3 negative 1. And then you can write this as basically 729 and write this as basically negative 2/3 negative 1. You can write it as negative of 2/3 plus 1. 2/3 plus 1 would be equal to negative of 2/3 plus 3/3, which is equal to negative 5/3. So I write this as 5/3 and multiply the negative sign by the expression, the numerator. So I write this as basically 1 minus negative 2/3 raised to the 7th power, and that's going to be your expression. Now what you can do is that, of course, you can write this as what 729 divided by 5/3 is 729 times 3 fifths times 3 divided by 5, right? And so you can write this as 729 times 3 divided by 5, and then basically write this as 1 minus basically negative 2 raised to the 7th power is let's call it basically 2 to the 7th power and let's call this 3 to the 7th power. Then you have a negative sign over here, multiply it here, and so you have basically this expression, which gives you basically 729 is 3 raised to the power 6 times 3 is equal to 3 raised to the power 7. So you have multiply it by 1, you will get 3 raised to the power 7 divided by 5 plus, and then multiplying it by this term, the numerator denominator here cancels out. You have 2 raised to the power 7 divided by 5, right? Divided by 5. So 3 raised to the power 7, I wish we had kept those values. Now I'm going to do this with the calculator. 3 raised to the power 6 is equal to 729. So 3 raised to the power 7 is equal to 3 raised to the power 6 times 3 is equal to 729 times 3, and 729 times 3 is equal to 27,268 and 2187. That's basically, that is equal to 2187. And 2 raised to the power 7 is equal to 2 raised to the power 6 times 2, which is equal to 64. That's 2 raised to the power 6, 128. That's 128, right? So if I add 2187 and add 128 to that, I'll get 5, 1, 11, 1, 3, and 2, 3, 1, 5. So I have 2, 3, 1, 5 divided by 5, which gives me basically 2, 3, 1, 5 divided by 5. That gives me 4 times 5 is equal to 20, 31. 6 times 5 is equal to 30, 15. 3 times 5 is equal to 15, 463. That is another value that you would get, but for whatever reason R has not been taken as 463. For whatever reason, R has not been taken as negative 2/3. So, and I do not really know why. There is no reason why you can't do that, but for whatever reason they have not done that. So I hope that you enjoyed this video. In the next video we will talk about the rest of the problems. I'll see you in the next video, and thank you.